So the last thing that we're going to cover in this section is the composition of trigonometric functions. That's when you nest one function inside another, an f of g of x problem. We did those with inverses once upon a time, and we saw that inverses and their functions always eliminated each other, and you got back to where you started. So, for example, if you take the sine of the arc sine of root 3 over 2, well, shouldn't sine and arc sine just cancel each other out and you get root 3 over 2? Well, it turns out often, yes, but not always, because of those restrictions. So let's take a look at arc sine of root 3 over 2. Let's see, that's a theta value. I'll call that thing inside the parentheses theta. And what I know about theta? Well, not much, but I do know that the sine of theta happens to equal root 3 over 2. And I know a lot of angles that do that, but the primary one, the main angle that does that, is in quadrant 1, and it would be up high, closer to pi over 2, so that would be the pi over 3 value, right? So, because the sine of pi over 3 is root 3 over 2, we know the arc sine of root 3 over 2 is pi over 3. So that means that I'm taking the sine of theta, but I know what theta is. It's pi over 3. So, wait a second. The sine of pi over 3 is just the square root of 3 over 2. We just got back to where we started. That is going to happen sometimes with these problems, but not always. This next problem you would say, oh, well, yeah, sine and arc sine just cancel each other out. The answer is 2. But wait. This is an angle, right? It's an angle whose sine equals 2. An angle whose sine equals 2? Nah. No solution. Remember that no cosine value is ever bigger than 1. Okay, what about going the other way and we put the trig function on the inside and the inverse function on the outside? So let's take a look. Sine of pi over 6. Oh, we know what sine of pi over 6 is. We'll just replace the sine of pi over 6 with 1/2, exactly. So then we take the arc sine of 1/2 and say, oh, wait a second, we're just back to where we started, pi over 6. So surely it's always just going to cancel out. But wait, we know what the sine of 2 pi over 3 is. The sine of 2 pi over 3 is positive root 3 over 2, right? Quadrant 2 gives you positive sine values. Okay, so we're looking for the arc sine of root 3 over 2. Didn't we just do that earlier? We just found that the arc sine of 3 over 2, root 3 over 2, is pi over 3. So we started with 2 pi over 3, and we went back to 1 pi over 3, and that has to do with the domain restrictions that we talked about on pages 2, 3, and 4. So you just kind of have to think about those domain restrictions, and you're going to get answers similar to what you would expect, but not always exactly the same thing back. Let's see, cosine of 2 pi over 3. Cosine of 2 pi over 3 is in fact negative 1/2, so we're going to say the cosine inverse of negative 1/2. That's what we're really finding here, but wait a second. We know that answer is 2 pi over 3, because we are familiar with taking the arc cosine of things from earlier. So we'll go ahead and move on to the next one, cosine of 5 pi over 4. Well, let's see. I think I can remember what the cosine of 5 pi over 4 is. We're in quadrant 3, so that means x and y are both negative. So it's negative root 2 over 2 should be my cosine of 5 pi over 3. When I take the arc cotangent, no, cosine, sorry, arc cosine, we don't go back into quadrant 3 because that's not part of our range, so we have to stick into quadrant 1 or 2. So the arc cosine of a negative value should put us in quadrant 2. So that would be 3 pi over 4. That's the quadrant 2 angle whose cosine equals negative root 2 over 2. So those are just more of the same. So we'll keep on going. The arctan of negative root 3. The arctan of negative root 3, well, that would be negative pi over 3. And then the tangent of negative pi over 3 is, we're just back to negative root 3, aren't we? Okay. So what if we do something like 11 pi over 6? That's not within the inverse tangents range. So it shouldn't spit out 11 pi over 6 when I take the arctangent of anything. So let's see, arctangent, or the inverse tangent of the tangent of 11 pi over 6. I believe that's negative root 3 over 3. So we're going to take the arctan of negative root 3 over 3, and you'll say, wait a second, that's quadrant 4, that's part of the domain, we are going back to 11 pi over 6. Yes, we are going back to that same location, that same angle, but instead of going the long way around, we're going to go the short way around. So that's negative 1 pi over 6. So the answer is going to be negative 1 pi over 6. Please don't forget, let's go back up and remind us all what we just spent some time on up here. Remember that the arctan function, the inverse tangent function, never returns values outside of negative pi over 2 and positive pi over 2. And 11 pi over 6 is bigger than pi over 2, so we have to stay within our restricted range. So that's where people normally mess up with these problems. Okay, so we'll keep on trucking. We are almost done. We've got now some compositions that don't match up. The cosine of the arc sine, and remember that this is the arc sine of 1/3 is an angle. Okay, what do we know about that angle? Well, not a whole lot. But we do know that the sine of that angle happens to be 1/3. That's what arc sine means. And I don't know that angle off the top of my head, but I do know that sine is y over r. So I've got myself a theta value like this, and I'm asking to find the cosine of that same angle. So let's zoom in on this. We've done problems like this. We now have to find this mystery value down here, so that would be the square root of 8 with the Pythagorean theorem, or 2 root 2 if you prefer. I tend to prefer that. So anyway, the cosine of theta is x over r, so 2 root 2 over 3. And that would be your final answer for that one. And the only tricky part about this, apart from knowing your trig definitions, is keeping track of which quadrant you're supposed to be in. So the inverse tan function is what we're starting with here. The inverse tan function is going to return either a quadrant 1 or quadrant 4 angle. In this case, since it's negative, will be in quadrant 4. Keep that in mind. That's important. So when we graph this, we're going to go, okay, tangent is y over x. So that's the negative, and we're down here. And theta is this negative angle right here. Okay? But I don't really need that graph because I already know that y equals negative 7 and x equals 1, because that's what's going to give us a negative 7 for the answer. And we have to take the sine. Well, for sine, we need r. So we need to find r using the Pythagorean theorem. And we've got 1 and 49, so we're going to end up with the square root of 50. Again, that's the right answer, but we can simplify that to 5 root 2 if we want to simplify it, which we should know how to do. Sine is y over r, so we've got y is negative 7 and r is 5 root 2. And to finish this off, we say, well, we can't have a radical in the denominator, if you care about that sort of thing. So 5 times 2 is 10, and we have our final answer. All right. Same old, really. So we've got this is theta. We know that the cosine of theta equals negative 3 over 5. So when is cosine negative? Definitely not in quadrant 4, which is good because inverse cosine doesn't return quadrant 4 angles. It returns quadrants 1 and 2. And in order for us to have a negative cosine value, we need to be an angle in quadrant 2. Remember, this is x over r, so we're over here in quadrant 2 with an x value of negative 3 and an r value of 5. We all know the 3, 4, 5 right triangle, so we know that y equals 4. So then we just do the tangent of theta, and theta's values, the x, y, and r values are known, so the tangent of theta equals y over x, so that's positive 4 over negative 3, or just plain old negative 4/3. All right. So, yeah, just pay attention to the quadrant you're in. Once again, this is an arc cosine problem, so we're looking at either quadrants 1 or 2. Since it's negative, we're in quadrant 2. X equals the 12, and r equals the 13. In quadrant 2, x is negative, so we've got a negative 12 and a positive 13 for the hypotenuse, the r value. So what's that y value? Well, some of you might know the 5, 12, 13 Pythagorean right triple. It's nice to memorize that. So y equals 5. Or you can just work it out with x squared plus y squared equals r squared, the Pythagorean theorem. Anyway, we end up with a known y value, so we can go ahead and answer sine of this value. So let's see, I'm running out of space, so I'll go down here. The sine is the y over r. We have a y value of 5 and an r value of 13, and that should be your final answer for that. Almost done. What? We've got variables in there. Why are they so mean? Well, we can do it anyway. We know that theta equals the arctan of 2x over 3. So tangent of theta equals 2x over 3. Well, tangent also equals y over x. Well, maybe I shouldn't use y as an x's because that x means something different, but we'll still keep that in mind. It's just that one of our coordinates, unfortunately our y coordinate, is going to have an x in it. Such is life. So our x value is 3, our y value is 2x over 3. There's our point, there's our angle, there's theta. All right. What is the y value? That's 2x over, no, just 2x, sorry. Just 2x. Because we're already dividing by 3 over here. So x equals 3. So what does r equal? Well, again, we've got the Pythagorean theorem, and we know that x squared plus y squared equals r squared. Well, my x value is 3, and my y value, strangely, is 2x. Again, that's not the same x as our x-axis, so that's a little confusing, but it's just a placeholder. Our answer is going to have x in it because x started out in it. So anyway, we know that r equals the square root of 9 plus 4x squared. That's my r value. So if I'm going to try to take the cosine of theta, well, oops, hold on a sec. Oop. All right. So we're going to find the cosine of that angle. The cosine is the x value, or 3, over the r value of the square root of 9 plus 4x squared. It's really more of the same thing. With these variable expressions, these algebraic expressions that we start with, just assume quadrant 1. There's no reason to mess around with other quadrants. X could be positive or x could be negative. So we'll just assume that x is positive just for simplicity's sake. Anyway, one last problem. This is, we know that the sine of theta equals 5 over x. So in quadrant 1, we've got a sine problem, so that's y over r. R is my x value, so we know that this is 5 equals y, and this distance down here, well, we don't know. But with the Pythagorean theorem, we can easily see that this is the square root of x squared minus 25. Hypotenuse squared minus 1 leg squared is the square of the other leg. So that's my x value. So if I'm going to take the tangent of that theta value, that's going to be the y. Oh, that's going to be the y value over the x value. So this would be our final answer.